recording here. So this 7th grade, this is 5-6, and we're solving two-step inequalities. And as I've explained before, solving for inequalities, when you're solving for a variable, it's much like solving for an equation. You just want to isolate the variable and get it by itself. And so I think what I'll do is probably teach this, but then there's a handout I'm going to give you guys, and I'll probably make the handout due today, and then maybe give you guys more time to work on this tomorrow, and then we'll grade that tomorrow at the end of class. But anyways, let's look at some of these together here. Example 1. It says, what is it here? Hamish has $25.97 in his pocket to spend on the craft store, or at the craft store. He wants to buy a paint canvas, so he's only buying one of those. And you can see right here that they're $14. And some paint pens. How many paint pens can Hamish buy? Well, the canvas is 14, so that's kind of a given. The pens are $3.15 each, so we don't know how many pens he can buy, but he can't go over that amount. So they tell you to write an inequality to represent the situation, and they did here, but I rewrote this as 315p because each pen is 315. Mr. Bone, do me a favor and just erase all that, please, because I see more eyes on that than over here. 315p plus 14. Where'd the 14 come from? Well, that's the cost of the canvas. Is less than or equal to $25.97. So he can't spend more than that. So there's the equation right there. And they go ahead and go through the steps of solving that for you. And then Hamish can purchase only whole numbers of paint pens. So he can buy 3 or less. It was almost a 4, but you don't buy 75% of a pen. So the most he could buy would be 3. The try it, I showed that to you guys earlier. And the convince me, I'm not worried about that. You can scratch that out. Let's look at example 2. Members of the Science Club are selling certain booklets for $17.95 as a fundraiser. They hope to exceed the amount of money they raised last year. And so again, they go through the steps here. This is how much money they've raised. This is the cost of one booklet. B would represent the number of booklets, and then last year's total. And so they have $498.75 plus 17.95 B. Again, the B is each book. We don't know how many they're going to sell. And that's how much money they raised last year. And so then you find out that B is greater than 8.89. Well, they're not going to sell a part of a book, so they have to sell at least 9. And that's what they have here. The try it, I circled that. So let me walk you through, because you'll get problems like this where you have to set it up. It says the jazz band needs to raise $600. So right there it tells me whatever else they tell us, it's going to be greater than or equal to 600. Then it says, and it's for some competition coming up. Then it says the members of the band have already raised $350. That's easy. So I'm going to come over here on this side and write 350. And then it's probably a plus. If they sell calendars for 8 each, how many calendars would they need to sell to exceed their goal? Remember, their goal is 600. So the calendars are each, so I'm just going to put 8C. And so now you need to solve for what C is. What would you do first? Subtract 350, subtract 350, because I want to get C all by itself. They cancel out. I'm just going to move this whole thing over here. So now I'm left with 8C is greater than or equal to, what is that? What's 600 minus 350? 250. All right. Now I need to divide each side by 8. Because I asked myself, what's happening to the c right here? It's being multiplied by 8. So I isolate it by doing the opposite. So c is greater than or equal to 250 divided by 8. No idea what that is. So 250 divided by 8. 8 doesn't go in the 2, but it goes into 25. How many times? 3 times. That's going to be 24. 1 left over. Bring down the 0. How many times did 8 go into 10? What's left over? Okay, I'm going to decimal right there now, because now I'm adding my own zeros here. How many times does 8 go into 20? 2 times. That's 16. Left over. Bring down another 0. Okay. 5 times. So the answer is 31.25. 31.25. Are they going to sell a quarter of a calendar? Like tear out 75% of it and say, there you go. Oh, so how many calendars do they have to sell? It's going to be 32. Okay? That makes sense to you guys? Because you're going to come up with some problems that are going to be in a fraction or a decimal, and you need to think about the problem and decide if that's applicable or not. All right, number 3, or example 3, solve the inequality. Everybody look at that. 5 minus 1/2 x is less than 30. Be honest, how many could solve that? Maybe half the class. Let's do it. 5 minus 1/2 x is greater than 30. Let me pull a stick here. Miss Kurz. And what's first thing you would do here? Yeah, subtract 5. Subtract 5. They cancel out, so we have a negative 1/2 x is greater than 25. Put up 50 points. All right. Ms. Lagarbo. Yeah. I asked myself what's happening to the x. It's being multiplied by a negative 1/2. So I'm going to divide each side by negative 1/2. They can't. Any idea?
Probably 15.
Well, think about it this way. If it wasn't 25, if it was 1, how many times does 1/2 go into 1?
Twice.
Yeah. How about 1/2 into 10? That would be 20 times. So what's 25 twice? 50. Is it going to be a negative or a positive? Yeah, negative 50. So x is less than negative 50. So there's that. Try it done for you guys. All right, put up 50 points each. Okay, let me see here. The do you understand It says, how is solving two-step inequalities similar to and different from solving two-step equations? Well, and my answer was both may involve adding, subtracting, multiplying, or dividing. But if it's an inequality and one of them's a negative, you got to change the direction of the sign. Of course, I didn't put that. But also the inequalities may have many solutions. Remember, if we had a solution that, let's say, x is less than 3, is 2 a solution?
Yeah.
Mr. Perry, what do you think? Yeah. How about 1/2? Is that a solution, Mr. Perry? Yeah. How about a negative 37? Is that a solution? Sure it is. If I was to graph this inequality, I could just put a 0 here. I could put 3 right here, draw a circle over it, and anything less than 3 would be considered a solution. So that's why I wrote inequalities may have many solutions, because this would have many solutions. All right, number 2. What's the difference between the number of solutions for a two-step equation? I'm sorry, let me slow down. What is the difference between the number of solutions for a two-step equation and for a two-step inequality? One solution versus many solutions is what I told you guys to write down for that. Number 3, why are inverse relationships between operations used to solve two-step inequalities? Because you use those to isolate the variable. All right, I told you guys to circle number 4 and underlined write an inequality and solve the inequality. And circle 5, 6, and 7. And then 8 and 9. Just do that bottom part on each one. For 10, A, B, and C, circle those. And then for 11, I told you to write down no more than blank miles per day. So you need to solve that one. And then 12, underline what inequality could you use to find the possible width of the roped off section. And then circle 13 and 14 and 15. It says use the diagram at the right. Write and solve an inequality to find the value of x for which the perimeter of the rectangle is less than 120. All right. So the length of this side right here, and I'll pull another stick, is x plus 4. And I'm not going to use Miss Gwen. Miss Stemler, this is a rectangle. If this is the length of this side right here is x plus 4, what's the length of this side?
X plus 4.
That's right. This is also x plus 4. If the length of this is x, what's the length of this side? X. Okay. So I'm going to write myself an equation here, or an inequality, because it has to be less than 120, it says. So I could even just write that, for starters, less than 120. So x plus 4, how many times is that? There's 2 of them. So I could write 2 times x plus 4 plus, what do we have here? 2x. Remember, there's always an assumed 1 in front of every variable. We just may not write it in there. So x plus x is 2x. So 2 times x plus 4 plus 2x is less than 120. Well, distributive property. What's 2 times x? 2x. What's 2 times 4? 8. And then continue on. Plus 2x is less than 120. And I just use the distributive property to do that. So do I have any like terms? I could combine Ms. Stimler, put up 50 points. Ms. Herrera, the equation. Is there any like terms I can combine?
2x.
Yeah, so that would be 4x plus 8 is less than 120. Still aiming to solve for x. What's the next step you would do, Miss Herrera?
Subtract 8.
Yeah, good. Put up 50 points. Subtract 8, subtract 8. So what do I have here? Now I have 4x is less than 112. Here. Mr. Fletcher, what would you do here? I'm kind of running out of room here. Let me write it over here. 4x. Yep, divide each side by 4. Left with x is less than, what is that?
28.
28. So x is less than 28. We didn't do any dividing or multiplying by negative, so we just keep the same direction for the inequality. X is less than 28. Put up 50 points, Mr. Fletcher. And Ms. Kurz, if you didn't already, go do so. Okay. So, you guys got a half an hour. Let me see here. Yeah, I think I'll just do this. I was going to give you guys a worksheet also, but I'll probably give you guys this tomorrow. And this is just some practice in inequalities. So I might put up a Math Excel, but we'll see. Kind of depends how hard you guys work on this. So that's it. Just about a 16